So let's do a slightly more advanced synthetic division problem. And again, when we look at this, it's got a lot more terms, but what we do is not going to be any different. We just have a little twist in this problem, an important point that we have to get to when we're doing this one. So when I look at the divisor on the bottom, the denominator of the fraction, okay, I am seeing that it does fit the criteria. It is x to the first power, right? It doesn't have any exponents, and there's nothing floating around in front of the x, because again, the problems that we do aren't going to handle that. So I'm going to start off by writing the coefficients of everything that I see in the top inside of my synthetic division symbol, right? But we have one little important note to make as we do this. So x to the fifth, I'm going to write down the 2, okay? And if you notice, what's missing is I don't have an x to the fourth, right? I go 5, missing 4, 3, 2, 1, 0. But I still need to represent that x to the fourth in my problem when I'm doing it. So I'm going to say, well, the coefficient to make me not see x to the fourth would be a 0. Right? So any terms that are missing in the numerator, as I'm writing out all of the coefficients, I need to put a 0 to represent those. So I'm going to keep moving. I'm going to say x to the third has a -1 in front of it, x squared has a 3 in front of it, x to the first has a -2 in front of it, and my constant term at the end is a 7. Right? So we're writing out the coefficients, not forgetting any that we missed, okay, because they're not in the problem, anything that would be a 0. Right? So now I'm going to do the same thing. I'm going to go to the bottom and I'm going to say, all right, I need to represent a number in this space, the one that I'm going to continually multiply through my problem, and it is always the opposite of what I see. So in this case, I see a -3. I'm going to write +3. Okay? And now we're going to start our synthetic division. So I'm going to bring down the first term. There's nothing to multiply, and I'm going to get a 2. And I'm going to say 3 times 2 gives me a 6. And that's what's going to move up, okay? And then I'm going to keep going. I'm going to say, okay, add down the column, and I get a 6. Well, 6 times 3 goes into the next spot. That's an 18, okay? Add down the column, and I get a 17. 3 times 17 is 51, okay? And I can add down the column and get a 54, okay? I'm going to say 3 times 54. Our numbers are starting to get big. That's okay. 3 times 54 is 162, okay? I'm going to add down the column. Well, -2 and 162 is 160. 3 times 160, okay, is going to go into this space right there, and that is 480. Okay, and I got to do one more addition down this column to get my last value in the space. 7 and 480 is 487. Okay, so again, it's that same process that we went through last time. Even though there's more terms, that really doesn't change what we're going to do. All right, so now let's write our expression. We have our answer. These are the coefficients of all of the terms of our problem, and we're going to start working our way backwards from the end. Okay, or if you just want to write it out, let's write this one front to back, but we're going to make sure that we do it correctly. Remember, the last term here, 487, is the remainder. Okay, so it's remainder, constant term, x to the first, x to the second, x to the third. It looks like this one's starting off with an x to the fourth. So if I want to write it left to right, which is, I think, how people normally write stuff, we know that this is the x to the fourth term. So again, remainder, constant, that's like the number at the end, like the 7, okay? X squared, x to the third, x to the fourth. So I'm going to say this is 2x to the fourth plus 6x to the third plus 17x squared plus, these are all positive numbers, so I'm just doing plus all the way along, 54x plus 160. Okay, I'm down to the end of a polynomial, right? Polynomials always end with our constant term. So this last term, the 487, we're going to say plus because it is positive. 487 over the divisor, x minus 3. So that remainder, just like in long division, is always going to be over the divisor. So I would say this expression, 2x to the fourth plus 6x to the third plus 17x squared plus 54x plus 160 plus my remainder, that is the quotient of my division problem.